This lesson is dealing with congruent triangles. When we are talking about congruent triangles, we are talking about triangles that are identical. So whenever you see the word congruent, it means identical, exactly the same. So if we read this first definition, congruent triangles are triangles whose corresponding angles and corresponding sides are congruent. So in other words, identical. So if their angles, the angles of one triangle are identical to the angles of the other, and the sides of one triangle are identical to the sides of another, then we say the triangles are identical or congruent. There are three different conditions for congruent triangles, and we're going to go through each one. So this is the first one. It's side, side, side. For short form, we call it SSS. So in side, 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 we're looking at the three sides of the triangle. So in these conditions, we need to have all the corresponding sides of the triangles are congruent. In other words, we need the side of one triangle to be congruent to the side of the other triangle. And we need the same for all three sides. So we'll look at this example here. We can see, because we're given lengths of sides, we can see which sides are congruent or are the same length or are identical. So we have side AB, that's this side, it's 1.5, and we also have side FE, that's 1.5. So we can say that side AB is congruent to side FE. Now when we are working with congruent triangles, often we're asked to prove if the triangles are congruent. And we can do that using geometric statements. So the first statement we're going to have here is that side AB is congruent to FE. Now we're going to look at our other sides. We have side CA, it's 5 centimeters, and we can see that side FD is also 5 centimeters. So we can state that CA is congruent to FD. And then lastly, we have side CB, and it's 8 centimeters, and side DE is 8 centimeters. So we can say side CB is congruent to side DE. Since we have three sides that are congruent, three pairs of sides that are congruent, then we can state that triangle ABC is congruent to triangle DEF by side, side, side. The symbol for congruent, if you've been wondering what that weird symbol is this. It's like an equal sign with a little squiggly on top. So that means not just equal, it means that they're congruent. It means they're identical in every way. So we're stating that triangle ABC is congruent, so we have this weird symbol, to triangle DEF, and then here we have to state in brackets how we know. Well, we know they're congruent by side, 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 because here we had the first side, the second side, and the third side. We proved they're the same. Now we'll go on to the second minimum condition. The second minimum condition is angle side angle, or ASA for short. And here we're talking about two angles and a contained side of one triangle are congruent to the corresponding angles and sides of another triangle. So we're looking for two angles and a contained side. When we say a contained side, we mean that the two angles that we're working with, the two congruent angles, well, they're on either side of this contained side. They're on either end. So the two angles are on either end of that contained side. I'll illustrate with an example. If you look at the next example here, we can prove that these two triangles are congruent using ASA. So if we look here, we have an angle that's 70, and then we have, in the other triangle, we have another angle that's also 70. And then we have this angle here that's 70, and we have another angle here in the other triangle that's also 70. So we have two pairs of congruent angles. This angle is congruent to this one's congruent to this one. Since they're both 70, like you could have done it the other way as well, it would have worked the same way. Now we need to look for a contained side. Well, this side is contained because you have the two angles you're working with are on either end of the side. And it's the same thing on this side. The two angles that we're working with, the 70 and the 70, are on either side of our contained side. It's inside the two angles. So these two triangles are congruent. Now we're going to write our geometric statements to prove that they're congruent. So for my first statement, I'm going to look at the pink angles. So this angle, if we want to name it, it's going to be angle BAC. So I write that, angle BAC is congruent to the other pink angle, which we'll name angle EFD. Then we'll look at the blue angles. So that's angle BCA is congruent to the angle EDF. Remember, when you're naming angles, the middle number, there's the letter, that's in the middle is always the letter that's at the vertex of the angle you're working with. So since I'm working with the blue angle here, the vertex is at D, so I need the D to be the middle letter in there. So we have our two angles. Now we're going to write our statement for the sides. Well, we know that side AC is congruent to side FD. So here we have an angle, we have another angle, and we have a side. And this side is contained, it's actually contained inside the two angles. So now we can state that triangle ABC is congruent to triangle DEF by ASA. For my first statement, I'm going to start with my pink sides. So I'm going to say that side AC is congruent to side DF. And then I'm going to state my my blue angles, angle BAC, AC is congruent to angle EDF. And then I'm going to state the green sides. So side BA is congruent to side DE. So now I've proven that these two triangles are congruent because I have a side, a contained angle, and a side. So we've proven they're congruent by SAS. So then I just need to write my conclusion. So triangle BAC is congruent to triangle EDF by SAS. So now I have another example for you to try. I'd like you to try this example. I'd like you to prove that the following pairs of triangles are congruent. I want you to write geometric statements just like I did in the other examples, and a conclusion stating that if the triangles are congruent and how do we know. Now, before you try this on your own, I think we should start by labeling the triangles just so we can have, our work will be similar. So I'm going to call this A, B, C. And this one's going to be D, E, and F. Okay, please finish this example and bring it to our next class.